Hello, good evening, Lamya.
Good evening, sir.
Okay, so wait for a few minutes. We will start within a
Okay, sir.
couple of minutes. Okay.
It's okay. Yeah.
Okay. Hello. Good evening, all of you.
Good evening, sir.
Okay. So let's start our today's session. Yeah. So in our last class, we basically discussed about charges. What is charge? What its properties? Okay. So the complete lecture was based on electrical charge. So today we will discuss some problems related to that topic, and we will also start our uh, new topic, which is Coulomb's law. Okay. So in our last lecture, I discussed one of the property of charge, which is quantization of charge. Quantization of charge. Yeah. So quantization of charge. Quantization of charge. Okay. So what are some other properties? I discussed three properties of charge. Three properties of charge, and the first property which I discussed.
Additivity.
Okay. Wait. So the first property I discussed, which is additivity. Okay. And the next property I discussed, which is conservation of charge, and this is the third one, which is quantization of charge. Okay, there are three basic properties, and there are some numericals related to this point, which is quantization of charge. Okay, so quantization of charge. So here I discussed that charge exists in the integral multiple of electronic charge. Okay, so the charge exists in the integral multiple of electronic charge. So we define charge. The formula of charge is Q is equals to plus minus of N E. Okay, here E is your electronic charge. Electronic charge. Okay, and N is the number where N is equals to, N can be 1, 2, 3 integral number. Okay, 1, 2, 3, 4. So in this way we define the charge. Okay, so suppose I have a body which have only one positive charge and one negative charge. Okay, so this is, suppose this, I'm considering a body which has one positive and one negative, or you can choose an atom where one proton and one electron revolving in its orbit. Okay, so in that case, the total charge can be defined as in this case plus minus. Okay, so if I consider only positive, so I consider plus. If I consider negative, so in that case I consider minus. Okay, so in this case I will choose E. Okay, so in this case we can write plus minus of 1e plus minus of 1.6 into 10 raised to the power minus 90. Okay, so here we know E is equals to, what is the value of E? The value of E is 1.6 into 10 raised to the power minus 90. Okay, so charge exists in the integral multiple of this number, which is 1.6 into 10 raised to the power minus 90. Okay, suppose I am considering another body which has two positive and two negative charge. So in that case, we define plus minus 2e, and that is plus minus 2 into 1.6 into 10 raised to the power minus 19. That will be plus minus 3.2 into 10 raised to the power minus 19 coulomb. Okay, if I choose another body which has three charges, three positive and three negative charges, in that case I can define plus minus 3e, which is plus minus 3 into 1.6 into 10 raised to the power minus 19. Okay, so that will be plus minus 4.8 into 10 raised to the power minus 19 coulomb. Okay, and so on and so on. So charge exists in the integral multiple of electronic charge, which is E. Okay, so for n number of, as I choose 1, 2, 3, if I choose another 4, then I can say plus minus 4e, or plus minus 4 into 1.6 into 10 raised to the power minus 19, and that will be plus minus 6.4 into 10 raised to the power minus 19 coulomb. Okay, so for n number of charges, I can write this formula as plus minus n e, where n is equals to 1, 2, 3, 4, and so on. Okay, so this is all about quantization of charge. The quantization of charge is basically is important. Why? Because a very small numerical can be asked in examination. Okay, for related to quantization of charge. Is it clear, or you have any question? Is it clear, or you have any question? Minashi, is it clear?
Yes, sir, clear.
Okay, so what is the value of E here?
1.6 into 10 raised to minus 19.
10 raised to the power minus 19. Okay, so now let's do a small problem related to this concept. Okay, so calculate the energy carried by, question. The question is calculate the energy carried by 12.5 into 10 raised to the power 8 electron. Okay, so now here, what is given here? In this problem, here we have the number of electrons. So we know the value of n. N is equals to 12.5 into 10 raised to the power 8. Calculate the, wait. Calculate the, not energy, calculate the charge carried. I'm sorry. Calculate the charge carried by 12 into 10 raised to the power 8 electron. Okay, 12 into 10 raised to the power 8. Okay, so now what but what we have to find? We have to find the basically the value of Q. And what is given here? Given here is 12 into 10 raised to the power 8. These are basically number of electrons. Here 12 into 10 raised to the power 8 is the number of electron. So if you want to calculate this charge capital Q, so what we have to do? We have to multiply it with, what is the formula? Q is equals to Ne. So we have to multiply it with the electronic charge, which is 1.6 into 10 raised to the power minus 19. Okay, so what will be the answer in that case? Okay, you can calculate it. It's a very small problem. Okay, so another question. Let's do one more question. Calculate the number of electron. Calculate the number of electron corresponding to 1 Coulomb charge. Okay, calculate the number of electron corresponding to 1 Coulomb charge. So 1 Coulomb charge, you have to find the number of electron. Okay, so now try to solve it. What is the formula? Formula is Q is equals to Ne. And what is given here? Lamya, what is given here?
Yes, sir.
What is given here in the problem? In this question, calculate the number of electron corresponding to 1 Coulomb charge. So what is given here? Q is equals to Ne. You have to find N. Okay, and you already know what is the value of E. So what is given here?
Ne.
No. Ne is the value. N is basically number. Okay, integral number. It may be any number. And E, you know, the value of E is fixed. As I told you, 1.6 into 10 raised to the power minus 19. Okay, so the variation can happen between Q and small n. Q and small n. So here n, you have to find small n. Then what is given here? Q basically given here. Q is equals to 1 Coulomb. And what is the value of E? E is equals to 1.6 into 10 raised to the power minus 19. So what is the value of N here? N is equals to 1 Coulomb divided by 1.6 into 10 raised to the power minus 19. So here you can find the exact number. So if you divide 1 divided by 1.6 into 10 raised to the power minus 19, that the value is 0.625 into 10 raised to the power minus plus 19. Because when 10 raised to the power minus 19 goes up, then it becomes positive. So 10 raised to the power positive 19. So what is the value? You can write it 2.65 into 10 raised to the power 18. Okay. So these are the number of electrons. These are the number of electrons. Is it clear? Hello? Is it clear?
Yes, sir.
Yes,
Okay.
sir.
Let's do one more problem. Yeah. The question is, find the electric charge on alpha particle. Okay. Alpha particle is an important particle. Okay. You will see in your entire syllabus, there are a lot of questions numerical based on this alpha particle. So that's why I am discussing alpha particle. So that's basically you guys are used to this particle. So some particles are very important. You have to remember what is charge, what is the mass of some particles, such as electron, neutron, proton, okay, and alpha particle. Okay, so find the electric charge on alpha particle. So one more thing which I'm giving you in this question, that alpha particle has charge twice of proton. Twice of proton. Alpha particle has charge twice of proton. Twice of proton charge. Proton charge. Okay. So tell me, how many guys here? Let me see. Maziha. Hello.
Yes, sir.
So in this problem, what is given here?
The electric charge.
Find the electric charge on alpha particle. What is given here? Electric charge. So what is the value of you have to find basically what is the electric charge. It is not given. It's the question. Now try once more.
The number of alpha particles.
Okay. So the number here is given n, which is 2. Okay. So proton has one charge. So if I ask the charge on proton QP, so that that is basically E plus E. Somebody messaged me. Okay, sir, answer is 3.2. Okay. So Abdul Rahman send me the correct answer. So QP is equals to plus E. Okay, so alpha particle has 2 positive charge. Alpha particle has 2 positive charge. So in that case, the charge on alpha particle is plus 2E. Okay, plus 2. Here for proton, the value of n is 1, and for alpha particle, the value is 2. Okay, so for alpha particle, the value is 2. So in this case, you can write 2 into 1.6 into 10 raised to the power minus 19. Okay, so what the value you can get here, that is 3.2 into 10 raised to the power minus 19 coulomb. Okay, so this is the answer. Okay, so I think this is enough for charge. We discussed some numerical on based on this Q is equals to NE. Okay, so I think all of you get familiar with charge. What is charge and what its properties? Okay, now let's start our next topic, which is Coulomb's law. Coulomb's law. Coulomb's law. Okay. Coulomb's law. Okay. So Coulomb's law, if I consider two charges, suppose I consider a charge Q plus Q1, and I consider another charge which is plus Q2. So what happened? These are similar charges. So what happened when you bring these charge close to each other? Then what happened? These two charges basically repel each other. These two charges basically, but they will repel each other. So it means they are applying some kind of force on each other. What kind of force it is? It is a repulsive force. So it's a different from gravitational force, because gravity always attracts. If you bring two massive body very close to each other, then they will attract each other. But in this case, what happened? They are rippling. If I consider they are rippling and they are applying some force. So the calculation of that force can be estimated through this Coulomb's law. Okay. So what is strength of force these two charges basically applying on each other, that can be calculated through Coulomb's law. Okay. Okay. So if I consider another two charges, suppose I'm considering a plus Q1 charge and minus Q2 charge, so in this case, these two charges will attract each other. Okay, because dissimilar charges, opposite charges attract each other and same charges repel each other. Okay, so now what kind of force this is, what is the mathematical form of this force, basically I'm going to discuss with you. Okay, so according to Coulomb's law, according to Coulomb's law, according to Coulomb's law, the electric force between two point charges, according to Coulomb's law, the electric force between 2 point charges. Okay, so here I'm considering 2 point charges. 2 point charges. What is a point charge? What is a point charge? Anyone have idea what is point charge? Okay, so I'm giving the answer. The point charge is a charge. Point charge is a charge on a body which has 0 dimension. 0 dimension means it's like a point. We consider point as 0 dimension. We consider line as a 1 dimension. We consider surface as 2 dimension. We consider sphere as 3 dimension. So point has 0 dimension. Okay, it doesn't have any length, breadth, and height. So it has 0 dimension. So if a body which has a point size body, if a point size body has a charge, so we consider that as point charge. So basically, protons and electrons are very fundamental particles, so they can be considered as a point charge. Okay, so if I consider 2 point charge, suppose I consider a charge Q1, a charge Q1. Okay, and I consider another charge Q2. If I'm considering another charge which is Q2, okay, I'm not considering here sign because they can be attractive or repulsive. I'm just calculating the strength of force. Okay, so in this case, if these two charges are separated by a distance small r, we always take the distance from center to center, from center to center. Okay, from here to here, no, from center to center, and they are separated by a distance r. Okay, so in that case, the strength of the force is directly proportional to product of magnitude of these two charges, means this F is directly proportional to Q1 into Q2, product of magnitude of these two charges. Okay, and this force is also directly proportional to or inversely proportional to, okay, this force is also inversely proportional to 1 by r square. Okay, 1 by r square. If I am talking about inversely, so r square. Okay, or you can say F is directly proportional to 1 by r square, the square of separation distance between these two charges. Okay, this force is also proportional to. So what is the mean? It means if I am containing a charge q1, I am containing a charge q2. So if I am increasing the value of these charges, so force will increase. And if I am increasing the distance between these two charges, then what happens? This force will decrease. And if I decrease the distance between these two charges, then force will increase. So if I bring two charge very close to each other, then the strength of force will increase. If I separate them, then what happens? The force will decrease. Okay, so if I include these two equations, okay, the equation first, which says that the force is directly proportional to q1 into q2, and another equation which says that this force is directly proportional to 1 by r square. So if I include these two equations, so we can say that this force is directly proportional to q1 q2 by r square. This force is directly proportional to q1 q2 by r square. Okay, r square. So if I remove this proportionality, if I remove this proportionality, so we can have a constant. So F is equals to K Q1 Q2 by R square. Here, what is the value of K? We say K is electrostatic force constant. Okay, we call K as electrostatic force constant. Okay, so this is the magnitude of this force. F is equals to K Q1 Q2 by R square. F is equals to K Q1 Q2 by R square. Note down. Take a note. Are you taking notes, all of you? Hello?
Yes, sir.
Yes, sir.
Take a note with me. Should I scroll down? Okay. So F is equals to K Q1 Q2 by R square, where K is electrostatic force constant. So in SI unit, what is K here? I'm describing what is K here. So in SI unit, we define K is equals to 1 upon 4 pi epsilon naught. This is the value of K, which is 1 upon 4 pi epsilon. And what is the value of this? Another constant, which is epsilon naught, Here, you know what is the value of pi? It's 3.14. You don't know what is this value, epsilon naught. What is this value? So epsilon, we define basically epsilon as absolute permittivity. Epsilon as absolute permittivity. So what this epsilon naught says, if I talk epsilon, there is a general form, it's a absolute permittivity. But if I consist but it for a particular case, means if I consider it for a vacuum case, so we consider as epsilon naught. It's a permittivity of free space. Permittivity of free space or vacuum. Okay. So if I put these two charges in vacuum, then we consider it as a epsilon naught, which is permittivity of free space. If I put this charge into another medium, okay, if I put this charge in some another medium, then we talk about this absolute permittivity or E. Okay, so that is basically permittivity of the medium. Okay, But if I consider it for vacuum, then I will choose epsilon naught, which is permittivity of free space. Okay. Or we can find the exact value of epsilon naught, which is a constant. For vacuum, it is 8.85 into 10 raised the power minus 12. It's a Coulomb square per Newton meter square. Okay, Coulomb square per Newton meter square. So this is the value of epsilon naught. Okay, so this is the value of epsilon naught. So if I put the value of K in our force formula, so what's the exact formula we can have? What is the exact formula we can have? F is equals to 1 over 4 pi epsilon naught Q1 Q2 by R square. Okay, so this is the formula for your Coulomb's law. This is the formula for your Coulomb's law. Okay, so here Q1 is charge, Q2 is charge, and what is R here? What is R here? What is R here? Hishima, what is R here?
So the distance between the two charges?
Yeah, the separation distance between two charges. And what is epsilon naught here? Mohammad Saifullah. What is epsilon naught here? Hello? Are you listening me, Mohammad Saifullah?
Yes, sir, I can listen you.
So what is epsilon naught here?
Permittivity of free space.
Permittivity of free space or vacuum, we can say. Okay. So what is the meaning of this permittivity of free space? It means if we put this charge in vacuum, then it's a permittivity of free space. If we put these two charges in some medium, then it will be absolute permittivity. Okay. Okay. It's also important what kind of medium you are using. What kind of medium you are using. If I consider these two charges in air, in water, in vacuum, then the value of force is different. It varies from one medium to another medium. Okay, it's okay. So all of you know what is vacuum. What is vacuum? How you can define a vacuum? Abdul Rahman, but how can you define a vacuum? And Maziha told me what is vacuum. Hello, are you listening me? Okay, any other one who wants to give the answer of this question? Yeah, somebody send me a message. A place where is no pressure. Okay, so we basically define vacuum as where there is no medium. Okay, for sound wave requires a medium. Okay, it requires some air. Okay, so most of the waves we consider, it requires a medium. Okay, but light can travel, or electromagnetic wave can travel in free space. Electromagnetic wave can travel in free space or vacuum. Okay, so now this is our force. The value of force is 1 upon 4 pi epsilon naught Q1 Q2 by R square. For derivation purpose, we will consider this formula. F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square. You don't need to remember this, the value of this epsilon naught. You don't need to remember this value. Epsilon naught is equals to 8.85 into 10 raised to the power minus 12. But for numerical purpose, we will consider this formula. F is equals to K Q1 Q2 by R square. We will use this formula for numerical purpose. Okay, all of guys, you know K is equals to 1 upon 4 pi epsilon. Okay, or the numerical value of this k is 9 into 10 raised the power 9. Okay, 9 into 10 raised the power 9 Newton meter square per coulomb square. Newton meter square per coulomb square. One, ठीक है. Okay, Newton meter square per coulomb square. Now this value you have to remember 9 into 10 raised the power 9. Okay, or the value of 1/4 pi epsilon naught is 9 into 10 raised the power. You can also remember in this way. Okay, or you can remember this in the form of k. Capital K is equals to 9 into 10 raised the power 9 Newton meter square per coulomb square. Okay, so this is our Coulomb's law. So have you studied any other formula which is exactly similar to this force formula? Any other formula? Do you guys remember which is exactly similar to this formula? Okay, have you remembered the value of force for gravitation force? What is the value? So for gravitation force, we use F is equals to capital G m1 m2 by r square. Okay, so Coulomb's law is exactly same as gravitation force, but the strength of Coulomb force is much greater than gravitation force. Why so? Because the constant you are using here, the constant you are using k, is very different from this constant g. Okay, is very different from constant g. Okay, so that's why the Coulomb force are so stronger. These are basically atomic forces. Okay, these are the forces between a positive and negative charge at the atomic level. These forces basically these forces are shows their behavior. Okay, and the gravitation force affected at the large value. Okay, for large massive bodies such as Earth and Moon. Okay, so here you can observe gravity. For gravity, you require some enough massive body. So gravitation force is a weak force, is not as strong as electromagnetic forces, electrostatic forces. Okay, so there are four kind of forces we always talk in nature. There are four kind of forces. Okay, so the first force we talk is gravitational force. And the next force is electrostatic force. Okay, and gravity acts between two massive body, and this electrostatic force works for two charges. And there's another force which we call nuclear force or strong nuclear force. Okay, this force exists inside the nucleus. And another is force is also nuclear force, but we called it weak force. Okay, it is stronger than gravitational force, but it is weaker than strong forces. That we called it weak forces because the last two forces are nuclear forces. Okay, so four forces forces explain the entire nature, or you can say that four forces exist. Okay, so here we are going to study only electrostatic forces. In our modern physics chapter, we will also consider that two forces, strong nuclear forces, and in that chapter we will study some radioactivity. Okay, so here I will discuss only electrostatic forces. In your previous classes, you already done a course on gravitational force. So next, here I'm going to show the value of k in SI unit. In SI unit, the value of k is equals to 1/4 pi epsilon naught. And in CGS unit, the value of k is 1. In CGS unit, the value of k is 1. So the formula F is equals to, in CGS unit, is Q1 Q2 by R square. Q1 Q2 by R square. Okay, so the SI unit of force, what is the SI unit of force? Minashi, what is the SI unit of force?
Newton per meter.
Newton. Newton per meter square is
Newton.
not, is a Newton. And what is the CGS unit? Hishima, what is the CGS unit of force?
Dynes.
Dyne is a CGS unit of force. Okay, so in CGS unit, K is equals to 1. So force, for the formula for force is Q1 Q2 by R square dyne. Okay, so this is your SI unit, this is your CGS unit. In CGS in SI unit, we take 1 upon 4 pi epsilon naught Q1 Q2 by R square. Okay, so this is all about Coulomb force. Any question related to this Coulomb force? Any question? Okay, so next I'm going to discuss some properties of Coulomb's law. Okay, properties of Coulomb's law. Coulomb's law. Okay, so the first property of Coulomb's law is what we basically find in Coulomb's law. We basically find the force between two charges, the force between two point charges. Okay, so the Coulomb law work very well for point charges. Point charges means some point charge here, some point charge here, some point charge here, some point charge here. Then you can apply Coulomb's law and you can find some that net force for these charges, what kind of force they are applying on each other. You can easily find by using Coulomb's law. But this Coulomb's law fail for a continuous charge distribution. Suppose if a rod is positively charged, so in that case Coulomb force not works. Okay, so this is the first property, that it is valid only for point charges. It is valid only for point charges. Point charges or spheres. Okay, it is only valid for point charges or sphere, or you can say that discrete system. For discrete charge system, it works very well, but for continuous charge distribution, the Coulomb law fails. For that, we will study Gauss law. Okay, Gauss law. Coulomb's law works better for charge particles, point-like charge particles. But Gauss law works very well for continuous charge distribution, so that if a long wire, if you take a long charged wire and you are interested to find force and field around this wire, so for that we use basically Gauss law. Okay, Gauss law to find electric field, and by finding that electric field we find force. Okay, so that I will discuss in our later classes. Now next, let me very clear for this. Okay, is it clear? The first point, it is valid only for point charges or sphere. Point charges or sphere. Suppose I consider a point charge something very small, Q1, and another point charge which is Q2. It works very well. And if I consider a sphere, which is charge sphere, which is plus Q1, and if I'm considering another charge sphere which is plus Q2, okay, then this works very well. But if I'm considering a charge distribution, if I'm considering a continuous charge distribution plus 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 plus, or another charge distribution, okay, which is plus 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 plus, okay, so in that case F is equals to K Q1 Q2 by R square don't work. It doesn't work in this case. It only works for these 2 points. So this is a one of the property of Coulomb's law. Another point, next second point, it is valid only, it is valid only if both the charges, if both the charges are static, or at least one of them is static and distance between them does not change. Does not change. Okay, so let's try to understand this statement. So this law, Coulomb's law, is valid only when these two charges, two charges are static, means they are placed, okay, at a separate distance. They are not moving. They are fixed at their position. So this law works very well if I consider two charges and they are static. Okay, and these charges, basically, if these charges are moving and they are separating, their distance is changing with time. So in that case, Coulomb's law doesn't work. Okay, doesn't work. So if I consider a charge plus Q and another charge plus Q, and they are moving. Okay, they are moving. That means they are moving with different velocities. Then what happened, if their separation distance is increasing or decreasing, then this law is not exactly valid. But if I fix the charge here, suppose I fix a charge plus Q here, and a minus Q charge is moving around this positive charge as inside the atom. Okay, inside the atom. So here one charge is fixed, one charge is static, and one charge is continuously changing its position. But the separation distance between these two charges is fixed. It's not basically changing. So that's why you can apply Coulomb's law here. So there are two cases. The first case, charge must be static. The charge must be static, and if one charge is changing its position, then the another charge must be static, and the separation distance between these two charges is not changing. So in that case, you can apply this Coulomb's law. Okay, you can apply this Coulomb's law. Is it clear? Okay, is it clear, all of you?
Yes, sir.
Yes, sir.
Okay. Next point, third one. It is conservative force. Electrostatic force is a conservative force. Electrostatic force is conservative force. Okay, electrostatic force is a conservative force. For that we used Coulomb's law for that, because we are studying properties of Coulomb's law. So Coulomb's law, you can find the force between these two charges, and this force is a conservative force. Okay, this force which you are estimating through Coulomb's law is a conservative force. Okay, conservative. What are conservative force? Minashi?
Yes, sir.
What is conservative force? Have you heard this name conservative force in your class, previous class?
Yes.
So can you explain? Can you give me a very small answer for conservative force? Okay, so let me explain. There are two. You studied three kind of conservative force. Okay, the first one is gravitation force. In previous class, basically two conservative force you studied. The first one is gravitation force. Gravitation force is conservative force, and another conservative force you studied is spring forces. These two forces are conservative force, and another which is non-conservative force you studied is friction force, is a non-conservative. Okay, the definition of conservative force: the work done by these forces are path independent. I will briefly discuss what is conservative force in my next classes. Okay, so here I think this definition is enough for you guys. These the electrostatic forces are conservative forces, means the work done by these forces are path independent. Okay, path independent. It doesn't depends on path. Okay. So next, one more property of electrostatic force, or Coulomb's law, you can say. The fourth one is it is central force. Electrostatic force is central force. Central force means these force apply between center to center, the center of one body to center of another body. In center of one body, these force act from this center of one body to center of another. We always consider separation distance between the center to center. We always consider the separation distance between center to center. Or as a gravitation force, if you consider gravitation force, so the gravitation force act between moon and earth is we consider from the center of the earth to the center of the moon, because these are also central forces. These act from center to center. Okay, is it clear? Okay.
Yes.
So what we studied up to now, we studied briefly what is Coulomb's law. Coulomb's law acts between between two charges. Charge must be point-like charges. The charge must be point-like charges, and the charge must be static. And if one charge is moving, then another charge must be at fixed point, and the separation distance must be constant. And these the electrostatic forces are basically conservative forces, and these forces are also central force. Okay, and what is the formula for estimating the Coulomb's law is 1 upon 4 pi epsilon naught. Formula to estimating the force is F is equals to 1 upon 4 pi epsilon naught q1 q2 by r square. q1 q2 by r square. Okay, q1 q2 by r square, where the value of 1 upon 4 pi epsilon naught, what is the value of this? It is 9 into 10 raised the power 9. Okay, r square. Okay, okay.
Yes, sir.
So next, let's try to do some problems based on this formula, which is F is equals to 1 upon 4 pi epsilon naught q1 q2 by r square. Let's do some question. The question number 1, if I consider a charge minus 2 microcoulomb, another charge which I am choosing here, 3 microcoulomb. Okay, these two negative charge, if I am considering these two charges are negative. Calculate force between them. Okay, Now try to find the force. What is the formula? Formula is F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square. Okay. Are you guys are familiar with micro? Here I take a term which is microcoulomb. You know what is the value of micro? Huh?
10 raised to minus 6.
10 raised to the power minus 6. Okay. So the value of micro, we consider 1 micro is equals to 10 raised to the power minus 6. Okay. So here 1 microcoulomb. So 1 microcoulomb is 10 raised to the power minus 6 coulomb, big charge. So F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square. Now calculate it. Everyone try to calculate it. And one more thing. Wait a minute. One more thing. The separation distance is 3 meter. Everyone calculate it and give me the answer. It's a very easy question. Give me the answer in chat box. Yeah. So 6 into 10 raised to the power minus 3. Okay. Abdul Rahman. Okay, all of you are calculating correct answer, but the problem is in within power. 10 raised to the power minus 3. Okay. And okay, let me try to solve this problem. Okay, some of you give the correct I think answer, but the problem is in power, the power. So I am giving you the answer. 1 upon 4 pi epsilon naught, the value of 1 upon 4 pi epsilon naught is 9 into 10 raised to the power 9. And here the charge Q1, I am only taking the magnitude of charge, only magnitude, no sign. For sign purpose, we will use the vector form of Coulomb's law. Here I'm only considering this magnitude, which is 2 into 10 raised to the power minus 6. Another charge which has 3 into 10 raised to the power minus 6, divided by the distance between them is 3 meter, so 3 square. Okay, so here 3 3s are 9, 9 you can cancel out, and here 3 2s are 6. 6 into 10 raised the power into 10 raised the power minus 12. So here 6 into 10 raised the power minus 3 Newton is the correct answer. Okay. So some students send me the answer with 10 raised the power, plus I think 3. Okay. So, okay. So here actually, why this force is very low? Here you notice that the value of force is very small. 6 into 10 raised to the power minus 3 is a very small Newton. It's a very small force. Why this force is small? Because I choose the separation distance is very long, very large. 3 meter is very large distance if you consider uh, for charges. So the distance 3 meter is I think a very long distance. So next problem, in my next problem, I am choosing a very small distance. So you will get the effect, the change in force, the how much the strength in force varies with r. Okay, you can compare with these two questions. In my next question, I am considering a minus 2 microcoulomb charge. I am choosing the same number, and minus 3 millicoulomb charge. Here I'm using milli. And now in this case, the separation distance is, this distance is 3 now millimeter. Now try to solve this question.
How much is 1 millimeter?
Okay, so you consider 1 millimeter is equals to 10 raised the power minus 3 meter.
So it's a millicoulomb.
Okay, millicoulomb. So that's same. Millimeter as millicoulomb. 1 millicoulomb is again 10 raised the power minus 3 coulomb. Milli, we consider milli as 10 raised the power minus 3. Now try to find the answer and give me the correct answer. Hishima. Okay. Try to revise your calculation, Hishima. Abdul Rahman. Again. Okay, I think you guys are facing problem with this question, huh? If the numeric quantities are same, then answer must be same. The only change will appear in power. Okay, now Ishmael, your answer is correct. Abdul Rahman, you also have to revise your calculation. And other guys, Saifullah, are you doing this problem?
I send you.
Okay, you have sent me. It's not showing in chat box actually. Okay, that's okay, correct. So let me solve this question. Let me solve this question because some guys send me not the correct answer. Okay. So in the difference between these two problems is only the distance term. If I'm using again that my formula f is equals to k q1 q2 by r square. Here the value of k is 9 into 10 raised to the power 9. Okay, I'm solving it very quickly. And again 2 into 10 raised to the power minus 6. And again 3 into 10 raised to the power minus 3 divided by r square. And what is the value of r? What is the value of r is 3 millimeter. So 3 into 10 raised to the power minus 3 the whole square. Okay, so here you will get 9 into 10 raised to the power 9 into 6 into 10 raised to the power minus 9 divided by 9 into 10 raised to the power minus 6. So here 9 and 9 will cancel out, and this power minus 9 and plus 9, these are also cancel out. The value which remains is 10 into 10 raised to the power. When this 10 raised to the power minus 6 go upside, then it has positive value 6 into 10 raised to the power plus 6. So this Newton force, the answer is this. So what happened when you put this charge at 3 meter distance? When you put this charge at 3 meter distance, then the force is 6 into 10 raised to the power minus 3. And when you consider this charge at 3 millimeter, then the force goes to 6 into 10 raised to the power plus 6. This is a very strong force. It's a very effective force, 6 into 10 raised to the power plus 6. If you again decrease distance, okay, if you go to the micro level, or if you go to the atomic level, so this force is very powerful because the separation distance is decreasing. If you decrease separation distance, then this force will show its effect very strongly. Okay, I think from these two numerical you get the idea about the Coulomb force. Next, I'm giving you one more problem on this Coulomb force. Okay, next problem is two charges Q1 and Q2 are placed at separation small r, repel each other with force F. Repel each other with force capital F. Calculate force. Calculate the new force, calculate the new force if magnitude of both charges, if magnitude of both charges, if magnitude of both charges is doubled, okay, and separation is halved, and separation is halved. Okay, try to solve this problem. Okay, first try to understand what is the language of this problem, what this question is saying. Okay, so after that you just have to keep the values, just increase or decrease the value according to the problem, and you will get the exact answer. Mohammad Saifullah. Okay, you send me the answer, but I think you have to revise your calculation. I think your approach is correct, but you just do a very small, I think, calculation mistake. But you are very close to answer. All of you try this question. Only one guy send me the answer. What about others? Huh? Are you guys facing problem in this question? Huh? Only one guy send me the answer. Are you solving? Minashi and Hishima?
Yes, sir.
Okay. So Saifullah, are you revising your calculation? Have you find any error?
According to me, it is correct only.
Okay, okay. Then just wait. In match with my calculation. Okay.
Okay, sir.
Okay. Just wait. I'm waiting so that one or two more guys give me answer. Send me the message so that I can compare. Okay. So now let me solve this question. I think you guys are facing problem with this question. Let me solve. Okay, I'm going to solve this question. So compare your approach and your calculation with me. So what is the question? It says that two charges Q1 and Q2 are placed at separation R. Okay. So first case says that I'm taking a charge Q1 and I'm taking another charge, okay, Q2, and these two charges are separated with a distance small r. Okay, so this is the first case. So in this case, what is the value of force? What is the value of force? F is equals to K Q1 Q2 by R square. Okay, Q1 Q2 by R square. Next, what question says? Calculate the new force if magnitude of both charges is doubled. Magnitude of these two charges are doubled and separation is halved. Now these two charges comes close to each other, and the first charge goes to 2q1 and another charge goes to 2q2. Okay, and in this case, the separation distance is halved, r by 2. So what is the new force? The new force I'm writing this force, new force as of F1. F1 is a new force. So F1 is K twice of Q1 into twice of Q2 divided by R by 2 the whole square. Okay. Now let's try to calculate this value. So here you can have 4k Q1 Q2, 4k Q1 Q2 divide by R square by 4. And what is the value? This will give you 16 capital K Q1 Q2 by R square. Okay, so here this is the value of F1. This is your old force, which is F is equals to K Q1 Q2 by R square, and this is new force, which is F1 is equals to 16K Q1 Q2 by R square. Okay, so if I divide these two equations, suppose this is equation number 1, this is equation number 2. If I divide 2 by 1, if I take 2 by 1, so in that case, the value F1 divided by F is equals to K Q1 Q2 by R square divided by 16K Q1 Q2 by R square. Okay. Okay. So next, what you will get, this K Q1 Q2 and this gets cancel out. Q1 Q2 by R square. Wait a minute, I just switched value. I'm again writing this. F1 by F1 value has 16K Q1 Q2 by R square, and the value of F is K Q1 Q2 by R square. So you can cancel out this K Q1 Q2 by R square. The ratio between these two forces is F1 upon F is 16. So the new force is F1 is equals to 16F. This is your correct answer. Okay. So Sapullah, now you find where is your error? Have you find it?
Yes, sir.
Okay. Is it clear to all of you? Huh? Maziha, Abdul Rahman. Okay. So these kind of questions can be asked in your examinations. Okay. So about Coulombic force, they will give you two charge. They will give you some separation distance. You have to find the force by applying Coulomb's law. Then you will write formula F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square. And there is some another type of questions, such as if separation distance doubled or halved, or charge doubled or halved. In that case, the force varies, the strength of force varies, and you can also find the ratio. You can also find the change between the difference. Okay, all kind of things you can do by this formula, which is F is equals to 1 upon 4 pi epsilon naught R square. So this is F, which is 1 upon 4 pi epsilon naught Q1 Q2 by R. This is your Coulomb's law, which I discussed today. The whole lecture is based on this Coulomb's law. Today's lecture we complete discussion was on based this Coulomb's law. And somebody asked me, why, sir, K, why we are not taking as 9 into 9? Yeah, we are not taking 9 into 10 raised to the power 9 here, because there is no need to put value. Okay, there is no need to put value here. Why? Because here K and this K get cancel out. This K and this, the K which appears here and the K which appear here, these are basically same. So there is no need to put value. There is no need to put value, because at the end they are getting cancel out. Okay, they just cancel out. Here what we are studying that if charge doubles and separation is halved, then the strength of force increases 16 times with its old force. Okay, so this is another question related to comparison of force. Means if you increase magnitude, decrease distance, then force increase. Okay, so then force increase. So that's why there is no need to put the value of K, because at the end K gets cancelled out. Okay, so this is all about Coulomb's law. If any other question, you guys can ask with me. Okay, so here I'm not going to start with another topic. Here I'm stopping the complete lecture based on this Coulomb's law. In my next lecture, I will discuss what is dielectric constant and relative permittivity and some electric field. Okay.
Yes, sir.
Okay. Okay, guys. Then we will meet in our next lecture.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Okay, welcome. Okay, if you guys don't have any question, then I'm closing this meeting.